Yeah, you're in charge now.
Okay. Hi guys. I'm really sorry that I couldn't be there in person, but luckily Machine have saved the day, so I can at least present remotely, if not in person. So the topic for today would be machine all the things, a very buzzword nowadays. So my name is Una Verhoeven, and I'm a senior solution developer at Hedgehog, and I'm also the member of SUCON and Saganel organization, and also one of the co-founders of CMS Machine Learning site, together with Amanda Scheiga and Mark Stiles. And these are the usual places where you can find me on social networks. So let's start. Uh, the biggest thing of the symposium, I think that it was announced, and which caused really the big hype, was the announcing of the Cortex, which Sitecore also likes to call the mind in the marketing machine. And the idea behind the Cortex is the contextual insights, content and commerce, and omni-channel distribution. But since symposium, there has been no other information about the Cortex, so it feels a bit like taking a candy from the baby. So while we are waiting to get any info about the Cortex, and we know that it's supposed to be for the machine learning on the Azure platforms, we can do at least some things to prepare ourselves. So this is what this presentation is all about, to get you some insights regarding the machine learning, to introduce you with the history of it, regarding AI and big data, what you should do regarding to Sitecore to prepare yourself, and I will explain some of the most commonly used models in machine learning with examples that I have built for this presentation. So let's go a bit into the history. We are hearing a lot about the artificial intelligence and the machine learning, and if you see any Gartner reports and quadrants, it's everywhere. It's really the hype and the buzzword. But if you look a bit into the history, the first time actually that the machine learning, actually the artificial intelligence, has been acknowledged is back in the 1300s by Ramon Lull. He was a philosopher, also the bishop in the Catholic Church, and he's credited to be the one behind the calculating machine, based on some recent records that have been found. The calculating machine was extended by Gottfried Leibniz and later on engineered by William Schickard back in 1623. And all of this has led to what we all know as Turing's machines back in the 1936. And basically, this was suggesting that machine, by shuffling symbols simple as zeros and ones, they could simulate any act of mathematical deduction. So several years later, in 1943, the formal design for the Turing complete artificial neurons was designed. But where the big break comes in is in 1956, which we consider the birth of artificial intelligence in Dartmouth College. And all of a sudden, people got really interested, but at the same time, something very strange has happened. A lot of science fiction novels were published in those days. So what happened was that artificial intelligence got ridiculed by many people. They couldn't understand what is behind it. But NASA and the system of defense by US has acknowledged it in the 1960s. So they put a lot of money into the research. And all of that went well until 1974, when it was heavily criticized. And this year is known as something as AI winter, where everything fell apart and people stopped working on it. But the base of artificial intelligence was actually set back in the 60s and the 70s and even in the 80s. So artificial intelligence comes back again in the 1980s as the new hype, because there was a big commercial success of the expert systems. And expert systems are a form of artificial intelligence program that simulate the knowledge and analytical skills of human experts. And it went really well until 1987, where there was a huge collapse of the list machine market. So again, we have a period of silence until the big break in 1997, the Deep Blue. In case if you don't know what a Deep Blue is, that is the famous computer who beat Garry Kasparov in '97 in the game of chess. And since then, the AI is really getting higher and higher, and it's getting more and more interested. But it's not a new concept. So what is AI? It's basically the machine intelligence. It is the intelligence displayed by the machines, and it is also known as a study of the intelligent agents. And very frequently what we're going to hear nowadays, together with AI and ML, is the term of the big data. Everyone is talking about the big data. And as you can see here on the screen, the Wired announced that data is the new oil of the digital economy. So why is all the data important? The data will give us informations. Informations are going to lead to the insights, and insights will help us in order to make better decisions. And IBM actually managed to define the 4 V's of the big data. I hope that you can see this picture on the screen. So it defined it in 4 categories: the volume, which is the amount of data that we actually have. And if you look with all social networks and different platforms and all ways that we are gathering data nowadays, the volume is humongous. Then we have the velocity, which is the analysis of the streaming data, which is also very big. I mean, if you look at the companies such as Netflix and others, which are streaming the data, or any other CDNs that we're using, you will realize that it's quite big. Then we have variety, the different forms of the data. So how are we going to classify the data that we are collecting? And we have veracity, which is uncertainty of the data. So basically the fake news that we're seeing nowadays, it's very difficult to determine what is true and what is false. But when it comes to the data, the amount of it is huge. Then how can we get the insights from the data? Because we have tons and tons of it. The answer to this question lays in machine learning. Machine learning is the part of the artificial intelligence that provides the system the ability to automatically learn and improve from experience without being explicitly programmed. And this definition was defined back in 1959. When we talk about machine learning, very often people are going to mix AI and ML, and they think it's the same thing. The thing is, artificial intelligence is really a huge field. There are so many other things apart from the machine learning, but the machine learning is the most known part of it. So it's just part of it. And let's say since somewhere in the 2000s, it also got introduced into deep learning algorithms. And why deep learning? Because we need to analyze all the big data that we have. And why now? So if you have looked in the timeline, which I have shown quite recently, AI and ML are nothing new. So what is the difference that we are starting to use it now and not before? Well, the reason for it is now that we are actually having the hardware and capabilities to actually accumulate, store, and process that data. I mean, can you imagine how it would be back in the 60s? I mean, we still did not have internet. Or in the 90s, while we were still on dial-up, it was just too difficult to accumulate all those things. So how can you get started, and where is Sitecore in all this story regarding the big data and machine learning? We all know what XDB is, and we all know that Sitecore is tracking, tracing, and storing everything from what users have done through, if we extend it nowadays with XConnect. Before we were doing that with the tags. We also have facets. We have different CRMs. We can pull a lot of data into the XDB. And then Sitecore Cortex comes into a place, which is going to provide us the link between the data that we have in XDB together with Azure Machine Learning. That is at least how, at least me and a couple of us are assuming that is how it's going to be, but we're still not sure. What we do know is that the Sitecore Cortex is going to use R and CNTK languages. CNTK is being developed by Microsoft, and R is used on the Azure platforms. So we know that Sitecore is having lots of stored data. And let's say that we will now want to start to do the machine learning with Sitecore. The first question that we need to ask ourselves is, what do we want to achieve? So what is the ultimate goal that we want the machine learning to solve? If we don't know the answer to this question, it's a bit pointless to even start with it. It doesn't make sense just because it's the hype, it's something new. Let's use it just because we can if we don't know what to do with it. We also need to determine what data is important for the machine learning. Let's say that we want to define personas. So how can we classify all those people who have been clicking on our website? So if you look into the XDB, it doesn't make sense that we send email address or ID of the contact. That's just silly. We want to trace other things. So it's very important to distinguish the things that we actually want to use and what we want to use. And now, when do we want to start with the machine learning? Some people would say as soon as possible, but everything that I talked about so far and about the big data, it tells us that we should actually start when we actually have enough of data to work with. The more data we have, the better model we can make. So if you're starting with a new project and the client comes and says, okay, I really want to use the machine learning, we really, really need it. I would strongly advise you not to do that immediately, because with what are you going to define your model against with? It just doesn't make sense, and it's just going to bring you lots of costs. Also, you have a very high risk that if you have too little data, that you will define your model wrongly. So be careful with that. And I always talk about the data preparation, and Dilbert is my Bible, so maybe some of you know these comics. So we also need to make sure that the data is correct. And the big advantage of Sitecore and the data that we are storing in XDP is we have a very low risk of having trash. So if we have configured our XDP properly, we're not going to have robots. We're not going to have users who have trolled our database and put some random meaningful things. And that is actually the big impact of Sitecore and the data we have. If, for example, we're taking the data from Twitter, you would need to spend a lot of time cleaning the data, because there are so many things that you actually don't want to have there. And with Sitecore, that is one big step that you're going to miss out, and you should be very grateful for that. When it comes to the knowledge that we need to use regarding the machine learning, as you can see, it kind of overlaps between several different areas. And I'm not going to go into math and statistics and to show you formulas, but the base of the machine learning behind all that fanciness that we are seeing nowadays is math, and you cannot get away from it. And there is a certain terminology that you need to learn. And it's not something that can be implemented just by a Sitecore developer without any background knowledge. I will later on describe what kind of team you need and what kind of expertise you need to do something like this. But it requires a team, not just one person. So, as I have mentioned, the Sitecore data should not contain trash, and that is really important to keep in mind. When it comes to the machine learning doesn't work well with null values and empty values. And what you really need to be careful of, what it comes, not because of Sitecore 9, but because that's the law. I'm not really sure how much you're familiar with it. On 18th of May this year, GDPR comes to play. GDPR is a general data protection, and it's the right to be forgotten. And Sitecore 9 supports it, it comes with it. And basically what it does when it comes to the XDB, if the user comes to your website and says, okay, I don't want anymore that you store my data, I am not giving you permission, Sitecore will delete the cells in the database, but the interaction ID of the contact remains. And what you end up with is that you have, for example, built a model, everything is fine and dandy, and then the data which you're putting in, or heaven forbids that it ends up in the model, you're going to get empty values. And that is going completely to disrupt your system. So basically then what you need to do is you need to fill in that data which is empty with average values. For example, if we have a gender facet, you're going to take the amount of, let's say, if you had 60% of males and 40% of females, and you have 10 empty contacts, so 10 empty fields, you're going to define just randomly 6 males and 4 females. You kind of want to have the balance. You don't want to disrupt your data that it pushes more on one side than on the other. Or for example, if you have age, you're going to sum up the entire column of the age and just take the average age. It's kind of the neutral data, but just don't feed it with the empty stuff. And what I mentioned before, you really need to choose what is relevant for your model. So contact ID doesn't make sense. Email also doesn't make sense. So when it comes to the training the data, basically the values are 70% towards 30%. So if you want to make our model to give relatively good predictions, we need to train it with the 70% of the data we have. So on example of 100K, so 100,000 rows, we actually need to use 70,000, which is a huge number. We need to process it, to filter it, and then the rest of the 30% can be deducted by the machine. This is a very common thing, and it's strongly advised that this is how you should do it. You can also go with less depending on what you're doing, but the more data you put into training, the more correct results will be. So how does the machine learning work? So these are usual steps. It doesn't matter which model you're going to choose and which algorithm you're going to choose. These steps you always need to do. So first we need to select the data, model it, validate, tune the model, use the model, and test the model. So how do we select the data? So we're going to take, for example, our XDB and to split it into 3 sections. We're going to split it into the training data, the validation data, and the test data. When we have those 3 subsets, we're going to use the training data in order to define our model, and validation data we're going to use to validate our model. After that, when we check the performances, we can improve them by adding even more data or adjusting certain parameters in order to tweak it or adding certain features. After that, we're going to use it and to see what kind of predictions that model makes on our new data. And the test data we're going to use to check our performances. So these are the steps that you're always going to do when it comes to the machine learning. So I'm going to describe a bit the difference between the supervised and unsupervised learning. So machine learning comes actually with 3 types of learnings. The third one is the reinforcement learning, but that one also requires a bit of background in psychology. So I'm going to skip that one. So I'm just going to stick with the supervised and unsupervised learning. So supervised learning on the left side, we have a raw data, which in my case are orange and purple dots. And I want to pass it to the machine. So I'm picking the algorithm, and that data is split, like in the previous step, into 3 subsets by a data scientist and data analyst. So they're going to analyze this data, they're going to tweak it, they're going to see what needs to be improved, and they're going to check the desired output. Once the data analyst is happy with it, he's going to send that data back into the algorithm in order for it to be processed. So the output that we are expecting to see in this case is that we're going to get the 2 sets of purple and orange. So the example of the supervised learning, which is a very common one, would be OCR, which is optical character recognition. So we want to train our machine to recognize the numbers. So we're going to send different types of 9s, different types of 1s, pixelated, curved, handwritten, and in all kinds of formats. And let's say that, for example, we see that our model is very good in recognizing 1, 5, and 8, but for some reason, it's recognizing 9 as 8. And you really need to be careful when you're tuning your model, because when you're changing the parameters, you should be focused on the entire data, not just on the subset. Because what can happen is that you tweak it to perfectly work for 9, but that you destroy 1 and 5. So it is far better to have the full overview on the data that you're tweaking and not to focus on the subset, because even the small changes in the parameters that you're tweaking in your model can have a very big impact on the results. Now, when it comes to unsupervised learning, we are kind of skipping one part of the data analyst work. So you are feeding the machine with the raw data. Of course, the data analyst and scientists still need to pre-select it. The only thing that we do is we pick the model and algorithm, we set a certain parameters, and we just put the data into the machine. And it's kind of wait and see what happens. We don't know how the machine is going to interpret it. The only thing that we can do is we can analyze the data which we get as an output. Sometimes this can be a very risky procedure, because if you don't know what you're going to get, it's kind of engineering in reverse. So you constantly need to go back and to see what your machine has done. Has it been learned properly or not? And both examples have its uses depending on the algorithms which you choose. Some models only work with supervised and some models only work with unsupervised learning. It's not that you're always going to have the full control of what you're doing. It all depends on the model that you're getting. And the example that I really like to use in unsupervised learning, and I think that you all guys know this, is Microsoft Tay. And Tay was the Microsoft chatbot, the Twitter bot, which lived, I think, less than 24 hours. And the idea behind it was brilliant, and it actually worked in China. The Chinese bot is still alive and communicates with people. But basically what happened here is the Twitter bot got created and used the machine learning. So people who were tweeting to Tay, that was the data input. And what happened was what we see nowadays a lot, trolls. They just started taking a mock out of the bot and learning it completely wrong. So actually, the algorithm worked, but not in the way that we expected. But the human aspect of it, you can't predict what humans will do. So if they had, for example, a certain set of people, a certain group of people who would train it properly and for a very long time, maybe it would have performed better. But basically, what happened in this case, it really backfired. So it got killed in less than 24 hours because it was very abusive, racist, etc., etc. So this is the example for unsupervised learning. So what about the models? We know that we have the data that we need to work with. We know that we need to select a certain data. We know that we have two types of learning. So what about the models? Now, this list is not full. These are not all the models that exist. The list is actually quite huge. But I've picked one of the most common ones and the most used ones. And I'm not going to explain all of them. I'm only going to explain on some examples these three. And why have I picked these three? Because in order for me to explain any others, I don't think that you will be having any people left on this presentation, and there will be lots of math and statistics. And actually, these models are good and they're easy to understand, but you need to be a bit careful with it. So the first one that I'm going to pick is a decision tree. Decision tree is type of a classification model, and I think it's one of the most used models nowadays. And the reason behind it is it's simple to understand, it's very simple to test, but it's also the worst performance, which I will demonstrate in this example. So I'm a big fan of skiing and big fan of winter, which I'm missing now in Belarus. But as you can see here, I have a certain data set which I have created. So I want to determine in which case I'm actually going to be able to go skiing based on the weather conditions. So I have the outlook based how the day looks. I have the temperature in the second column. I have what type of wind it is, how much snow I have on the slope, and the outcome. So this is type of supervised learning. So what I'm going to do in this case, I'm going to make a decision tree going from left to right. So the first case that I'm going to take is the outlook. So I have several cases. It can be sunny, snowy, rainy, cloudy, and that's it. So let me create the first tree. So I have the outlook with all these 4 classes, and within these categories, this data falls in. So this data falls into the sunny category. This data falls into the rain category. What is marked red, that means that I'm not going to ski. That is how I'm training my model. In this category, I have several of them. So I see that I have branchings. I may go skiing, I may not go skiing. And in case of cloudiness, is the same. So if I look sunny and rainy outlook, I will see that I have a pure subset. Pure subset means that I don't have branching. So my data is not good. There is no need to classify it even more, because in all these my cases, I will go skiing. The same goes when it's raining. But for snowing, I have a certain difference. So I may or may not go skiing. The same applies for cloudiness. So what I'm going to do is I'm going now to pick the second column, which tells me what the temperature is like. So I have things as below -10, below 0, 0, and below -25, and above 0. So I'm going to take now that data and split it. So this is how the data looks. So when it's snowing, if it's above 0, 0, and below -10, I will go skiing. I will not go skiing if it's below -25, unless you booked skiing like I did for a week when the weather was like that, and then you have no choice. And regarding the cloudiness, so if it's above 0, I will not go skiing, and if it's below 0, I will go skiing. If I go back to my original data, so let's scroll this back, I've done everything correctly. So this is the original. I went from left to right, and I built the decision tree. But there is a problem. Let's say that we deploy this model to a traveling agency website. And currently it's January. This model will work. And let's say I go back to the same traveling agency website, and it's August, and I'm booking vacation to the mountains. My model says if it's sunny, I'm going to go skiing. And there is no snow, but this is what my model tells me that will happen. And if you look from the data that it was there, you've done things correctly. So this is one of the reasons why it's very easy to make a mistake with the decision tree. Even if what you can do in these cases is you can either switch your columns. So what will you pick that the first data is as an input, or you can add more data where you will actually have more of the branching, for example, when it's sunny or when it's raining. So of course, when it's raining, I'm not going to go skiing in any ways. That doesn't make sense. But when it's sunny, well, yeah, if there is snow, of course I will go skiing. So this is the problem with the decision tree. So if you're going to use it, make sure to use, don't go just from left to right like I did here. Play with columns. Play what is the first input, what is the second input. And if you're suspecting that you don't have enough branching, add more data. So now we come, the second model that I want to explain is called KNN, or K nearest neighbor. So it is type of the classification algorithm, and it's very simple. It's form of unsupervised learning, and basically what it does is it just calculates the distance from the data and checks where the data should belong. So the easiest for me to explain it is based on the example. So let's say that my examples are clusters of balls. Yes, not the best term that I could come up with, but let's say that we have a tennis ball, we have a soccer ball, and we have a basketball ball. And now I bought some ball and I need to place it somewhere. So where is going to fit in based on the data that I have? So the easiest way to show this is like this. So let's say that I have 11 orange balls with a certain parameters. I have 16 tennis balls, which are marked in blue, and I have 5 soccer balls, which are marked in purple. And my data of the unknown ball falls here. What this algorithm will do is going to check the nearest data, which is close to it. And it's going to pick, so if I say k equals 10, it's going to find 10 closest data next to my black data. So in this case, the answer is quite obvious. It's going to be blue. But let's make things a bit more complicated and let's put it in the middle. So in order to visualize this, these lines present equal distances between all three subsets. So I do apologize. So if you see here on the left, we have 4 of them which are orange, 1 falls into the purple, and we have 5 of them which are blue. So with my k being 10, so find me 10 nearest. These are 10 nearest, and the winner is the one which you have the most. In this case, that means that my ball is blue and it belongs, I think it was tennis ball. So, but what is the problem with the KNN? It's very difficult to determine the value of k. So how many subsets are you going to have? Are you going to classify your data to be 1, 2, 3, 4, 500, 1,000? So the best way to determine it is just to try it. And you're taking the data which is known to you, and you're pretending that you actually don't know what it is, and you see what the outcome is. If you put the k to be too low, you're going to have way too many clusters, and then they can be noisy. And that means that a lot of data which you actually have, which is valuable, is going to become invisible. But if you put it too large, you have a risk that you end up with only, if we're, let's say, going to talk about personas in Sitecore, that you're going to end up with one persona within a cluster. So let's say that you have 1,000 clusters, which doesn't make sense when it comes to Sitecore personas. You may end up that every cluster has one persona, and that's not something that you want to achieve. But if you want to use it for the heat maps, for example, it is a great model to do so. The next one I want to explain is k-means. The k-means is, and by the way, if you have any questions or some things are unclear while I'm talking, please feel free to interrupt me. K-means is the type of the supervised learning, and people make a mistake with the KNN, which I explained before. As I said, KNN just, you pick the data and it calculates the data which is closest to it and it associates. That's it. But k-means actually does way more than that, and it's a type of unsupervised learning, and it's used for clustering. So let's say that this is my data, and I want to divide it into 3 subsets. So I will say to the k-means that the amount of clusters that I want to have, which is also known as centroids. So centroid is the first data that gets randomly picked by the machine. So I want to say to machine, I want to have 3 of them. And machine will randomly pick them. So in my case, I have again, blue, green, and orange. And machine decides which ones are going to be. So then what the machine does, how this algorithm works, it measures the distance between the first point and initial cluster, which in this case, so it's going to measure the distance, and it's usually Euclidean distance. And what you will see if you implement any of these algorithms, there are way more distances and way more calculations. But Euclidean distance is commonly used because we all know what it is, and we all had it in elementary school. So it's going to calculate the distance, so between the first and the blue, then the first and the green, and the first and orange. And it will pick the one which is closest, which in our case is blue. So the first one becomes blue. But then what happens? It starts to calculate the mean. The mean is the average distance, so it's half of the distance between calculated winner. So in this case, between the 2 blues. And then what it does, it moves the center. So we previously had that the second blue dot was the center, but now our central point of calculation is this blue line, which is called the mean. So it will take the second dot, the second gray dot, and it will calculate the average to the blue mean, in this case line. And it's closest to it, it will become blue, but then it will recalculate it again. So now this is our central point, and it will take another unsorted data. It will become blue. The next one obviously will become green, and it will again do the recalculation and move its centroid. And the process is repeated as many times until all the data falls into a certain cluster. So I'm going to click this one through, so it recalculates the mean again and again until all data is filled in. So how our data looks? So this would be the result of what I just showed. Then the next time, the result can look like this. There are many ways how the result can look, but what you can see here is that the velocity of the data gets smaller and smaller. And these are the amount of iterations. So what I said to the k-means, okay, I want to have 3 clusters, but if you put only 10 iterations, that means that 10 times the k-means algorithm is going randomly to pick your starting points and then do the calculation on that, and it's going to pick the winner. The more iterations you have, the more precise your algorithm is going to be. But the more iterations you have, the slower it is. And all the machine learning algorithms and everything what you do with it, and if you're doing it locally, has high performance issues. So these are the notes if you're implementing the k-means in the R language. And R language is used on Azure. It will add a weight to each of the instances, and it means that it favorizes a bit more the larger clusters than the smaller clusters. And by default, it will always initialize one. So you really need to tell it how many iterations you actually do want to have. So this is, if you want to launch it in R, this is the example how it will going to look. So k-means the data, which is the data we want to place in. So the raw data, I want to have 3 clusters, and the amount of iterations I want to have is 100. Because people very frequently, and you will see that online, this is one of the most frequent questions, they mix these 2 algorithms. So I have split this part into 2 to explain what the differences are. So k-means is unsupervised, KNN is supervised technique. K-means is used for clustering, KNN is used for classification. With the k-means, the clusters are unknown because the machine is randomly picking them. And in the KNN, we actually don't care. It's just the number of the nearest data subsets, which are we going to classify. The k-means is used for market segmentation, social media trends, anomaly detections, and so on. But KNN is used for the regression testing and classification, where we actually know the target and variables beforehand. In k-means, centroids are randomly selected, and we have the clustering, which constantly it looks different because the data moves all the time until everything stops moving at the end when there is no more data to recalculate. And KNN doesn't have something like that because the prediction is just based on the distance. You are either close to me or you're not. But what about if we don't have Sitecore on Azure? There are other tools that you can actually use to do machine learning, and you can use this to build the reports for your clients. You can use some of this, you can even integrate with Sitecore, one of them being Power BI. You can integrate the reports, of course, if your client has the license. I'm a big fan of a RapidMiner, but that is a standalone tool and it's built in Java. But it's a drag and drop tool. It has a very big community, so it's very easy to start with it, and you don't need to do any programming. So the big advantage of the RapidMiner is you don't need any programming skills. It's drag and drop and change the parameters. Then we have Wolfram, which does have a programming language, and it's called Wolfram. And it's completely free. It's developed by university. And we have MATLAB, but that one is, of course, paid, but it's actually extremely powerful tool to use. So the only way that and Wolfram, you can kind of integrate with Sitecore because it has a Wolfram API, so you can make the connections towards it. And it has a very big database. So it all kind of depends what you want to do, but there are other ways to do machine learning and to use the machine learning and to provide the analysis, to provide the reports, and to give insights Yes, they may not be in real time like we expect, at least I expect that it's going to happen with Cortex, but it's more than what you have now. So what about the open source platforms? I made the list. It's more for the informational knowledge if you're interested in something like this. Each of the big companies actually has released one of they have open source their frameworks. And what you will see that is quite common for all of them, they're either developed in C++ or Python, but they provide APIs. So for example, the TensorFlow by Google you will use for deep neural networks. So if you really want to go deep dive into the big data, then CNTK or the cognitive services, you're going to use, for example, for the face recognition, for example, if you're building the fingerprint identification and so on. The Facebook is completely focused on the computer vision, the object detection, the image segmentation, and the classification. We have also Baidu's Paddle, which is a parallel distributed deep learning framework. And it's mostly focused on the OCR. So let's say I would use this, for example, if I would have a client which is dealing with the cars, so some kind of car dealership. So for example, for license plate recognition, because this is a very good example where you would use OCR. And we have the Amazon's deep scalable sparse tensor network engine. And that one is mainly used with the product recommendations. So this is something that may be good for the commerce. And we have Huawei's partially open source StreamDM. So this is actually the only part of Huawei's framework which is open source, and that is for the stream processing, which is brilliant if your client is doing a lot of stuff with the media, if they have their own CDN and so on. And a couple of others, the IBM and Airbnb have as well their open source stuff. So what about the team? Somewhere at the beginning of this talk, I mentioned that you need a certain knowledge in order to do this. And basically what should be the team for the machine learning? Okay, my icon here is with 3, actually it should be 4. You need a Sitecore developer, obviously. You need a marketeer, you need a data analyst, and you need a data scientist. If you're not prepared to invest in these 4 to be one team to do with the machine learning, or if client tells you, Sitecore developer can do it, or even worse, marketeer can do it, don't do it. That would it's just going to lead to nowhere because you're going to end up with the wrong data. Because I actually had that slide, I removed it because I didn't want to freak anyone out. But when the data actually comes out from the machine learning and when you need to analyze it, it's just a bunch of tables and rows with the statistics. And it's very ugly, and trust me, that is not something that you want to deal with. So let analysts and scientists deal with it and analyze it, and you focus on other things. And I'm hoping that this won't happen. So this is the comic which I found. So basically, yeah, we're just going to throw stuff into the machine learning and hope for the best. So please have your team correctly set. Otherwise, you're going to end up with something like this. So to conclude this talk, machine learning is important to give us insights. You need to keep your data clean and keep in mind the GDPR when it comes to place, and use your data average to manipulate the empty cells. Take your time to define model. Don't rush it, because this is not something that can be done in a week. These things take months to set it up correctly. And even if you're doing an estimate and client comes and tells you, do it in 2 months, don't. I actually know for a project from a certain client, they've been setting the data. So just filtering, not even building the model, just filtering the data for the last 6 months. So really take your time to set it correctly. I have provided here some references. So these are the links which I used in this presentation. And also within this presentation, you have some links which lead to certain websites from where I've actually taking the data, some images that you have seen as well. And for example, the last link, k-means versus KNN, is the table that I have presented and explained the differences. So if you have time, read this. It's actually a very good reading. So this is where you can find me. And to conclude this, let's focus on questions.
So, guys, any questions? Sorry, Una. Oh, yeah, we do have one question.
Thank God. Sorry, I'm very happy.
Hey Una, Łukasz speaking.
Of course.
Just maybe two questions in one. Maybe you can remember, or you done something like that. I'm just curious if you know real life examples of using data from XDB with machine learning. So that was the question.
Okay, and the answer to that question, I'm actually working on something that's very similar, and this is something that I'm hoping that things will change, and to me it kind of looks like it. The biggest issue that I've been having with machine learning and Sitecore has been MongoDB, because most of the tools that you have don't have a Mongo connector. So you need to download some kind of NoSQL or to write your own connector. Secondly, Mongo comes with a Bison type, so it's binarized JSON, so you need to write your own converter to actually filter it out. And then what happens, because it's a flat structure, it takes so much time to actually analyze the data, unlike SQL, where it's so simple, where you can import the entire table. So I try to do some things with the reporting DB, but I wouldn't advise to use reporting DB for these kind of things because it's just aggregated data. So I'm actually setting up currently Sitecore 9 website, which I hope it will be launched live quite soon. And I will use that data for the machine learning because for me, the biggest issue, I'm still working on it, has been the the MongoDB. And two other examples that I know have said exactly the same thing. We are struggling with Mongo. It's not actually realizing which methods you want to use in models. It's actually getting and filtering the data.
Okay, thank you.
So I'm hoping with Sitecore 9 that is going to change. And to me, it looks like it because the first SQL came out, and the way how Azure works, it doesn't work with Mongo. I mean, by default, if you're going to deploy everything on Azure.
Okay, thank you. Una, I don't think we have much more questions right now. But anyway, thank you for joining us. Thanks for the presentation and for actually making it to Minsk, at least virtually. Hope sometime you'll be here in person and talk to us and have a beer. Well, once again, thanks.
Thanks, guys. What can I say? Have a beer for me, please. And I'm really, really sorry that I wasn't able to make it.
Yeah, that's okay. Well, you're safe. That's good. Again, thanks, everybody. So I guess that's a night. We can call it an end. Thank you.
Thanks, guys. And enjoy your drink.